now we're going to take a look at the various ways of reading data from pandas, using pandas. We can get data from HTML tables on any web page. So there's a nice way of doing that. We can get data from Google Finance, from the Federal Reserve, from the World Bank, all kinds of places. So we'll take a look at some of these things here. CSV files, Excel files. I'm not going to do CSV in Excel here. We will definitely cover that in other classes as examples, but just so you know that we can do that if you want to already know that. So any HTML page that contains tables, we can use pandas to extract the tables from that page. So what are the tables in an HTML page? That tables contain the tag, this tag here. If I do insert, so anything that's inside so table tags typically contain a bunch of rows. So I have tr and maybe column 1, sorry, td, c1, /td, what the heck happened here? /tr. So I get this thing here, and you can see this comes as a table like this, right? So this is the basic table structure. So what pandas does is it provides us with a function called read_html that, given this function here, the read_html, that given a URL can go to the URL and pick out all the tables that are inside a table tags like this. So it looks for the table tags and then looks for the TRs and TDs to get the table structure out, and takes that stuff and shoves it into a pandas data frame, because data frames are tables anyway, right? So that's the idea here. So we call this function called read_html. So I can run this and I get this back here. I get my table back inside a df list variable. And what I'm getting back is a list of tables, because any HTML page can contain multiple tables. So right now it says I have just one particular table in that thing here. So that's just one there. And but it's a list containing one element, but it's a list. So to extract the actual table itself, I need to index it to the 0th element. There's only one element, and I can print that, and I get this data frame. So we've gone to the Bloomberg Markets Currencies page and pulled out the single table that is there that contains currencies, values, changes, net change, time, and a 2-day change, which is NAN for some reason, but I'm not sure why. But that's probably in the data itself. But so this is what it's pulling out for us. So we get this entire data frame now, right? And we can see it's a data frame. If I did type df, it tells me it's a pandas data frame. So that's a very convenient way of grabbing data from the internet. Any page you're interested in contains data in the form of a table. You just call read_html, give it the URL, and it's going to pull out all the tables from there. And if you note here that this has actually already, for us, it's and just to make clear the structure clearer, rather than using print, I'm going to just use df. It's the column names. It's figured out for us that the column names are inside the header column is there, contains currency, value, change, etc. So we already have that in a very usable structure for our things are there. If with the index it hasn't done, and index it will not do automatically, but you can specify the index, say if I want this to be my index, the EUR, USD, JPY, I can set the index to this and set in place equals true just to make there. Now I get a nice little table here that has the thing properly done for us. And we can now use our LOC to extract values from here. So this tells us that the euro to Swiss franc exchange rate currently is 1.0899 blah blah blah, right? So that's we can extract specific currency rates or changes or whatever we feel like. So change, tell me it's 0.002, all that stuff. Even the time, if I'm interested in the time, it's kind of a useful way of doing that. So this is a very nice way of getting data from there. The next thing you want to do is you want to make sure that we talked a little bit about chain indexing earlier. where we said we could, in this section here, where I said that you could either go drill down to a specific cell by either giving R2 comma B and lock, or doing chained indexing where you do df lock R2, so you get here a series, a data frame which contains the row information, and then you extract the B column of that series, which is going to be only one element. So this is called chained indexing, and this is just complete normal indexing or whatever you want to call it. So the results are slightly different, and we want to see what happens when you do these two things. Is that when you do chained indexing, what Pandas does is it creates a copy of the data rather than the actual value. So when you drill down and you get to this value here, for example, I'm using here, I take df.loc, I first drill down and get the row that corresponds to Euro USD, and then I get the value of the column chained. So this is now a copy of what's actually in our data frame. So now if I look at, and let's say I store this currently in EUR USD, I just store that value somewhere. I go and I do LOC and I change EUR USD change. So this is, I'm saying, get me this value, right, and change it to 1.0. Okay, and if I print these things here, I find that so it's telling me it's trying to set a copy of a slice from a database. So what it's doing is it's changed this df.lock. It made this returned a copy, and that copy is an ephemeral copy because I haven't stored it anywhere, right? So I'm not stored it anywhere. It's an ephemeral copy. I changed the value in an ephemeral copy to 1.0, and then when I look and access the same value again, or go back to the same location again inside my original table, I find that it's unchanged. And the reason is because I used chained indexing, it actually did that on a copy. So instead, I don't want to use chain indexing. I want to use direct indexing. And direct indexing won't work with a copy, but it works with the actual location. So now here I do df.lock EUR USD change. So change. This is no longer chained index. We're not using, we're not getting one thing first. We're saying go and get me that location. So here I go in and I change that to 1.0. So what this does is it creates a view of the database, of the data frame. So now it's sort of pointing to the actual location of the thing inside my data frame itself. And if I change this, then I find that inside my data frame, it has actually changed. The copy that I made and I stored inside another variable, EUR USD, that hasn't changed. And because that's copy, when I do an equal to here, it's actually creating a copy. But the original location has changed now because I did not use the chain indexing method to get it. Okay, that's the thing here. So that's the key here. So you have to be really careful when you're doing the data frame. When you're working the data frame, you want to make sure that if you want to work with a copy, you're working with a copy. If you want to work with the original, you work with the original. To work with the original, use this mechanism. To work with a copy, use this mechanism. And you'll be fine with that. As long as you're clear what you're doing, you'll be all right. Okay, just make sure you get that.